All right, so we have Alice and Bob are 10 meters apart, right? Alice's mass is 55 kilograms. Bob's mass is 72 kilograms. How far from Alice is the center of mass they form? So let's say this is x equals 0, because I want the distance from Alice anyway. So this is x equals 10. And so when we do the center of mass, you're going to do the mass of Alice times her position, plus the mass of Bob times his position, divided by the total mass. And this is just a calculator problem. All right, so that's how we calculate center of mass. That's the basic idea. Very straightforward. So 5.67 meters. Okay? And that's about close, more than halfway, like a little bit closer to them, right? 5.67 meters. Suppose Bob starts pulling the rope so he undergoes a displacement of 2.5 meters towards Alice. Okay, so he undergoes a displacement, so he's going to move this way 2.5 meters. What is the distance between them at this point? Now, here's the thing. They're pulling on each other, but it's internal to the system. So that means as far as external to the system, there are no forces acting on it. Okay? So that means the center of mass, which is here, ought to remain at the same spot. Okay, the center of mass is still going to be the same location, but now Alice is going to move some distance, we'll say x1. Okay, and we want to know what that x1 is. So the center of mass, again, is 55 times x1 plus 72 times... Now, he's located at a new location because he was at 10. He moved to the left 2.5 meters, so now he's at 7.5 meters. That's where his location is. X equals 7.5 now. And then divided by 55 plus 72. And again, because this force is internal, they're just sitting there. The center of mass should not have accelerated, right? So then you solve for x1 here. So you're going to take this number times 55 plus 72, then minus 72 times 7.5, and then divide by 55. I get x1 is equal to 3.27 meters. Okay, so now that is how far she moved, because she was at 0, now she's at 3.27, so that's how far she would have traveled. How far would Bob have traveled when he came into contact with Alice? Now, if they come in together, again, they should come into contact at the center of mass, right? So, for Bob, he'll have traveled to the center of mass, okay, because once they're like touching each other, we'll basically say they're point masses, they're right at it. Technically, they can't be right on top of each other because they have, some dimensions to them, but let's just assume that they're right on top of each other. So Bob is going to travel x minus 5.67, 4.33 meters. Okay. D, let's assume Bob was pulling a rope such he moved at constant speed towards Alice. Relative to Bob's speed, Alice's speed during the motion was... Now, let's think about what is the velocity of the center of mass right now? Well, it's 0 because the center of mass is not moving. Okay? Why? Because they were just holding there and they weren't moving to begin with. Even though they pull on each other, that's internal to the system. The total center of mass of the velocity is 0. Now, let's talk about like this. You can explain it through center of mass, but let me just kind of give you the equation that helps you understand this. M1v1 plus M2v2 over the total M1 plus M2. Now, here's the thing. You can multiply that. You get 0 is equal to M1v1 plus M2v2. Okay? Now, what are we going to say here in this scenario in terms of center of mass? Well, mathematically from this quantity, because Bob has a bigger mass, this is bigger, and these two have to add to 0. This is smaller. That means in order to add to 0, this one must be bigger. Okay, so that means Alice has to be moving greater than Bob's speed. Another way to think of it is Alice has further to travel to the center of mass at the same time, right? So Alice has a further distance to go. Bob has to go the same distance, and the center of mass is not going to move, right? So that's another reason, another way to explain. Or you could say, Alice has further to go to reach the center mass of the system, which is where they'll meet. That implies he has to move faster. There's two ways to think about it, okay? In terms of the velocity of the center of mass, and then the corresponding velocity of each object, or the fact that Alex has to travel further to the center of mass in the same amount of time, because they're going to come together, because the center of mass is not moving, right? The point in between them that we call the center of mass is not moving, right? So when they come, they meet at the center of mass at the exact same time.